Let's work through the power rule. So we're going to find the derivative of x cubed using the power rule. And that power rule tells me when I find d dx of x cubed, I'm going to bring that power out in front. So I get the 3 out in front. And then the power that I'm left with is the original power minus 1. So we end up with 3x squared. Let's do another one. So let's say that we have this time f of x is equal to, let's do 5x squared. As I'm applying the derivative here, so d dx of 5x squared, I can actually pull that 5 out in front. So I end up with 5 outside, and let's go ahead and apply the power rule to the x squared. So here I go, the 2 comes out in front, and I'm going to subtract 1 from my power. So I'm just going to squish in a little 2 minus 1 there. Let's go ahead and do the math to finish this one. 5 times 2 is 10, and x to the 2 minus 1 is going to be x to the first, or you can just write this as 10x. Next, let's take the derivative of a constant. So we're going to do d dx of 3. What we're really looking at here is a line up here at 3, and it's a horizontal line, 1, 2, 3. The derivative is a slope, and I can see that the slope of that line is equal to 0. So the derivative of any constant, of any number, is going to equal 0. Let's keep going. What if this time we've got the derivative of, let's do 5x. So we've got a power inside there. I can bring the 5 on the outside. I am going to write a power 1 on the x. We can go ahead and apply our power rule. So my 1 is going to come out in front. So I get 1x to the 1 minus 1. That's going to be x to the 0. So I end up with, you could think of this as 5x to the 0, but really we end up with just 5. 5x, that's going to be a line with a slope of 5, so it makes sense. Let's combine some. So if I do d dx of a polynomial, let's do 7x squared minus 3x plus 2. I can take the derivative term by term. So as I take the derivative of 7x squared, I end up with 7, and then I'm going to do the derivative of x squared. That's going to be 2x to the first minus 3. Now I'm going to do the derivative of x. The derivative of x is equal to 1, so I get a 1 there. And then finally on the end, I get plus the derivative of 2. The derivative of a constant is equal to 0. Let's go ahead and put our answer up here. As I do the math here, I get 7 times 2 is 14, and I've got that x, so I've got 14x minus 3, and the rest is equal to 0. So this is my answer right here. But what if we have a negative exponent? Let's do that one next. So in this one, I'm not starting with a negative exponent, but I really want to use the power rule. So I'm going to change that x to the 5th in the denominator to have a negative exponent. That's going to allow me to bring it up on top. So d dx then, this becomes 3 stays in the numerator. If I bring x to the 5th up to the numerator, it changes into a negative 5. Now I'm able to apply the power rule on the x to the negative 5th. 3 is just a constant multiplier, so I'm going to write that 3 out in front, and let's go ahead and do the derivative of x to the negative 5th. Negative 5 comes out in front, and I get x to the negative 5 minus 1. As I simplify what we've got, 3 times negative 5 is negative 15. Negative 5 minus 1 is going to give me a power of negative 6, and I know I can bring that negative 6 down into a denominator. So here comes our answer. Negative 15 is going to live in the numerator, and then x, I'm going to change that to a positive 6, lives in the denominator of our answer. So we can play around with these powers in order to get to that power rule. Similarly, let's say that we're doing a derivative of a radical. Let's say that we've got the square root of x. Well, I can think of this square root, there's an index of 2, right? It's a square root, so it undoes powers of 2. I'm going to rewrite this. I'm not applying the derivative yet. So this is d dx of x to the 1/2 power. If it was a third root, if it was a cube root, it would be x to the 1/3 power. If it was, say, a fifth root, it would be x to the 1/5 power. I've got a 1/2 power here, and I'm ready to apply my power rule. That 1/2 is going to come out in front. So we end up with 1/2 x to the 1/2 minus 1. If I do that 1/2 minus 1, let's do it over here. That's going to be the same as 1/2 minus 1, or 2 over 2, which is -1/2. Okay, so doing the math, I end up with 1/2 x to the -1/2. That's going to live in a denominator. So we get, in our fraction, 1 lives in the numerator, 2 lives in the denominator, and I can change that x to the -1/2 to an x to the +1/2 in my denominator. Now, I really want to have the same form as my original problem, so I'm going to write this as 1 over 2 radical x. Now, this might be the answer, but you might also need to rationalize. If we rationalize this, to rationalize this, I need to get the square root out of the denominator. So if I need to do one more step and rationalize this, I'm going to write this as 1 over 2 radical x. To rationalize this, I need to multiply by another radical x. That's going to give me a radical x squared, and I can cancel my square root. But whatever I do in my denominator, I need to also do in my numerator. So I get a radical x over a radical x. This gives me radical x over 2 radical x squared. I can cancel the square root and the square, and here comes the rationalized form of that answer, radical x divided by 2, and this is our answer. You are doing so great with these. Take a look at these next couple of videos. I've got the product rule, I've got the quotient rule, I've got whatever you need for your calculus class. Thank you so much for watching.